All right, today we got a new battery from Diypow. It had a little bit of a rough shipping, so it's kind of already opened up. But let's open it up. It's the easy slide out. All right, guys, and there's the battery. So this is a 48 volt 100 amp hour battery in a big old battery box. That's really neat. And it looks like this one's going to support Bluetooth, so that's really awesome. And I think, unfortunately, there's some stuff that was lost from the big hole in the side of the box here. I think the terminal bolts were lost and the manual, because I don't have either one. Here, we'll just rob them from here. All right, so let's look at the stickers on the battery here. It says normal voltage is 51.2. Overcharge voltage is 58.4. It says nominal. I think they meant nominal. Nominal capacity is 100 amp hours. Over discharge voltage is 40. Max discharge current is 100 amps. Cycle life at 100% depth of discharge is 2,000 times. The storage energy is 5,120 watts. And the maximum charge current is 50 amps. Let's charge this guy up and then we're going to do a capacity test. So I hooked up this Victron MPPT 120 and it didn't come on, so I checked the terminals here and I didn't get any voltage. So it seems as though I got 2.1 volts. So it seems like the BMS is shut down. And then I went looking on their website for the BMS app, which I can't find one. I searched for Diypow on the Play Store, still couldn't find one. And I tried the JBD app, the Dali app, and still couldn't find it. So I guess what we're going to do is we're going to plug in solar to this charge controller and maybe it will wake this up. So our charge controller is coming on. And Victrons are good about, you can plug the solar into it and it will boot off the solar. It doesn't actually need to boot off the battery. All right, so our voltage is now 56.79. We're still not pushing any power because that may be because we're still not seeing anything here. And I think what we're going to see is we're going to see the voltage that the charge controller is producing, 56.8. But that's not going to be what the battery is going to give us because it apparently is not waking up. So it may have suffered some damage or something via shipping. Oh wait, no, we actually got 51 volts. So it is woken. Alright, so we should be charging now. We're not taking a charge at all, I don't understand. Okay, yeah, I'm not able to get this battery to function correctly. I even got an inverter hooked up to see if I could pull anything from it. And the best I can do is I can hook the charge controller up and it appears to wake it up a little bit. You know, as we see right now, it's at 2.6 volts. If I hook the charge controller, if I power the charge controller up, it'll wake it up and then it'll show 52 point something volts. Yeah, so I've got the charge controller hooked up. It doesn't actually, the battery will not take any power. So I can now disconnect it and the battery will show a voltage of 52.3, which is within range. It needs to be charged, but it's within a range. And then I can turn the inverter on and it'll come on briefly, as you can see here. But then it goes right back off. And it comes on briefly again and goes off. So yeah, I don't know. This battery doesn't appear to be working. Alright guys, so since we're not able to get this battery to actually charge or discharge, we get to move directly to opening it up. And I've already banged the lid off pretty much. There we go. Now let's take a look. See at what might be the problem. I do see the BMS flashing over here. And I do see what looks like a Bluetooth radio right there. Looks like there's some penetration right here on this heat shrink material from these terminals. So hopefully that has not penetrated a cell. Also on this side as well. I'm going to cut away this piece of heat shrink to examine that further, because if we've got anything ruptured, I do not want to proceed. Looks like I don't really see anything leaking, but there appears to be slight damage to the side of a cell. Let's check out this location up here. There appears to be an indentation in the cell. Let's try disconnecting this BMS and maybe we can reset whatever the problem is here. So we got both removed. All right, let's plug them both back in. All right, let's see if we got voltage. All right, it says 52.6. All right, well, let's see if we can either charge or discharge now. You know, I feel like maybe the terminal shorted out on that battery. All right, so let's try to turn that inverter on. So it's on. Oh, it's back off again. Yeah, I think this battery is damaged. All right, guys, I've got fantastic news. We are now charging. We're pushing in 613 watts. I can also turn on the inverter now and discharge. See that by plugging in the little AC over here. So it comes on. So the battery is functioning as it should, finally. So basically what I had to do, and this is not something that's going to be something easy to do if you buy this battery and you have a problem, because it requires it to be opened. But what I had to do was I had to take this jumper, this alligator jumper lead wire, and connect it to the battery side of the BMS, and then jumper it to the negative side of the battery terminal. That's a common way to enable, to basically turn on the BMS. A lot of times you have to do that with JBD BMSs the first time you use them, Dali BMSs. After I did that, then everything started working properly. Also, I heard back from the company about the BMS app, so I got it. And for anybody using these batteries, if you want to find the BMS app, so if you go to the Play Store, and it's simply Bluetooth BMS. That's it. Bluetooth BMS is this one right here. And it does work. So let's load it. And there we go. It's showing 100% state of charge. I don't think it is. We need to allow the charger to fully charge it up, and then it'll be 100%. Shows the capacity at 100 amp hours. Shows our status is charging. Shows our health is perfect. Our cycle life is 1. You can scroll over to this next page. Shows our current, so we're pushing in about 11 amps. Temperature, the voltage, and then individual cell voltages. So all the individual cell voltages look good. They're all very close. 3.38, 3.37, 3.39 kind of area. I don't see, well, we got one that's 3.4, so that's a little bit higher than the rest of them. I'm going to let this continue to charge up, and when it's fully charged, we'll finally get to our discharge test. Alright, you guys, so this thing has been sitting out here charging up for many hours, but I came out here to check on it, and it was acting strange again. And now that I was having a hard time connecting to the BMS, but now that I'm finally connected to it, the cell 12 is saying 2.53 volts, and cell 13 is saying 3.76 volts, and then it's saying it's in over voltage protection. So the BMS is not actually allowing any charge or discharge. It's kind of back in that mode again. Now this is incorrect. I actually measured the voltages at the balance wires, and they're all 3.3. So we can try that. 3.34, 3.34, 3.34, 3.33. Okay, 3.33, 3.33, 3.34, 3.34, 3.34, 3.34, 3.34, 3.33, 3.34, 3.33, 3.33, and lastly, if I can get it, 3.34. So they're all perfectly fine. The cells are all 3.3, 3.34. Let's plug it back into the BMS. Yeah, so it's wrong again. Let's try to reconnect. And also, it seems like the signal's low. Yeah, just wrong. Something's clearly wrong with this BMS. All right, guys, so I contacted DIYPOW regarding the issues that I've had with this battery. And they agreed that the viable option was to replace the BMS. So they were going to get me a BMS. And they said that their colleague that was coming to some trade show in the US would deliver it to me. Well, I never got it. So I'm going to continue on with the video. I think we're almost pretty much done here actually, because I don't know what else we could do short of replacing this BMS. But I will point out what I think. I mean, obviously this had shipping damage, but I think for them to minimize that damage, they need something underneath these terminals so that they're not banging into the cells during shipping. Something like a fiberboard. This may not be strong, thick enough to actually prevent that. I think they need like a really thick fiberboard like this one right here. So this one's very thick. I don't think those terminals would be able to penetrate that, and it would distribute the load of this impact across these cells up here. So they need something in between, like something like that, so that these terminals, so at the bottom of these terminals, don't bang into the cells. If this is bouncing up and down in a truck, I would assume that probably at some point this thing was completely upside down, where the weight of those cells were probably hitting the back of those terminals. There's a lot of things that can go ugly in shipping. I completely understand that. I've shipped a lot of stuff myself. So I think there's a lesson for DIYPOW. I think you guys need to put something between the cells and these terminals to prevent those terminals from banging into the cells here. I suspect that the BMS is damaged because maybe this ground out, maybe it's shorted, maybe the negative shorted or something like that to the casing of the cells. I suspect. I don't know for a fact, but it's kind of my suspicion. The other thing that these guys would probably want to do, this is a very heavy battery, so it'd probably be wise to double box the shipping. So you need to have this in foam packing inside a box, and then that box inside another box, just to give you more structural strength. But yeah, there we go. I think that's going to be the end of the video. Let me know your comments. I always love to hear what you guys have to say, and I'll catch you on the next one.